Hello everyone, I am Sahana K from the Department of Chemistry and working in a Maharaja Institute of Technology, Mysore. In today's class, I am going to take up the module second, which is energy conversion and storage coming under a ECE branch. So now in this module 2, we have a energy conversion and storage. So this module comprising of a basic sub concepts as batteries, fuel cells and solar energy. So it consists of batteries, fuel cells and solar energy. So these three are the main subtopics of this module. So in today's class I am going to explain you the batteries in detail, and here in this module the energy conversion and storage. So what it suggests, energy conversion and storage. So the name itself suggesting it's a conversion of energy from one form to another form and storing of this energy in the different devices. So here we are converting the energy from either chemical energy to electrical energy or from electrical energy to chemical energy and storing it in a devices. So these concepts will come and explains the concepts of battery. So batteries are nothing but it's a combination of two or more galvanic cells which is connected either in series or in a parallel combination and stores chemical energy. So in this here storing chemical energy means it is in the active form. The materials are in active form and on demand. It's on demand, it converts the chemical energy into electrical energy through a electrochemical redox reaction. So here we are observing the redox reactions where oxidation and reduction is taking place simultaneously. So batteries are the consisting of two or more galvanic cells connected in a series or parallel that can store chemical energy in the form of active material. On demand, it converts chemical energy into electrical energy through electrochemical redox reactions. So wherever we will see with the batteries, it's all undergoing a electrochemical redox reactions where it undergo oxidation simultaneously in turns with a reduction. So when we come with the concepts of battery, it is a consisting of two or more galvanic cells. So what is this galvanic cells? So galvanic cells are nothing but cells which converts the chemical reaction directly into a electrical energy. The chemical energy will directly convert into electrical energy. So here will consist of two or more numbers of galvanic cell which is connected in series or parallel connection that can store energy in the form of active material. And on demand it converts from chemical energy into electrical energy through electrochemical redox reactions. So either it can be changed from chemical energy to electrical energy or electrical to chemical energy. So it's a vice versa process. So in this batteries, wherever we'll go, in electronic gadgets, toys, appliances, everywhere we'll have a batteries. So, but all these batteries are same. Can we use the same battery in everywhere, each and everywhere? For example, remote, TV remotes. Another example for the battery is cell phones. We'll use the battery. So, can we have the same kind of battery in both the things? It is not possible. We cannot use the same battery in both the cases. So, first we will see with the remote. So, where we will use a cells or a battery, where we will again use it, and once the life is completed we will use another one and discard the older one. But whereas in the cell phones, will we do the same thing? No, it is not the same case, where we will charge the cell phones. We will charge the cell phones and again we will use the same cell phones. So, here the kinds of battery, or will come for the classification of battery as there are three major classifications of battery. One is primary battery, another one is secondary battery, third one is reserve batteries. So, we will study one by one. So, first is primary battery. So, second one is classification of batteries. So, next is classification of the batteries. So, first one is primary battery. So, primary batteries are nothing but the batteries which cannot be recharged, or which cannot be reused. So, once the cell is, or once the battery is used, it cannot be reused again. So, here the chemical reactions are not reversed. So, only when we take this batteries, we have to use it for the maximum extent, and once it completes its life, we have to dispose that batteries and we need to buy new one. We cannot charge this battery again. So, for example of this such kinds of battery are, so nothing but zinc manganese dioxide battery, lithium manganese dioxide battery. So, the primary batteries are not rechargeable batteries. Example for this is lithium manganese dioxide battery or zinc manganese dioxide battery. So, second one is secondary battery. So, secondary batteries is nothing but a rechargeable battery, where we will use with the cell phones, where we can charge the battery and again we can use. So, in this secondary battery, once the reactions are carried out, usually in the batteries we have two charging cases, one is discharging case and another one is charging case. So, once the discharging case is completed, again we can charge this battery by applying higher voltage than that can be produced by the battery. So, we can recharge this battery again by applying by giving high voltage than that of the battery produced. So, for this it is a rechargeable battery, and here we can apply the external source to recharge the battery, so that here the reactions will go in a reverse direction. So, once the forward reaction is completed, while charging again it has to come with a reverse reaction. So, here both forward and backward reaction is favored. So, here example for such kind of battery are lead storage battery and nickel cadmium battery. So, the third one is reserve battery. The name itself giving you a clue, reserve. We can reserve it. So, the reserve batteries are nothing but batteries where we are keeping the active material apart from the cell components. Here the components that usually are electrolyte, which will circulate throughout the batteries. We will keep this electrolyte apart from the cell component, and whenever it is needed we will connect it and we will use it. So such kind of batteries are nothing called as reserve battery. Here the key component is kept apart from the cell component. Example for this kind of batteries are magnesium silver chloride. Example for this is magnesium silver chloride battery. Magnesium silver chloride batteries, and one more example what we can give is magnesium water activated battery. Magnesium water activated battery. These are the few examples along with the classifications of battery. So next we need to move on to the components which is present in the battery. So what are the components present in the battery? So generally it's nothing but electrodes. Two electrodes. Generally we will use two electrodes. One is cathode and another one is anode. So here in the section of components of the batteries, we generally have major four components. One is anode, another one is cathode, third one is electrolyte, fourth one is separator. So what is this anode? Here we can see the diagrammatic representation of the components of the battery. Here we have the anode compartment and cathode compartment, in which the anode active materials is filled inside the electrode, and here it is comprising of cathode active material. Here it is comprising of both anode and cathode compartment, where in the anode active materials are filled, in the cathode active materials are filled. In the center of the battery there is a presence of separator which separates the anode and cathode, and then we have the flow of a liquid which is known as electrolyte. So this electrolyte have a chance of flowing throughout the cell from anode to cathode, or in between the cathode and anode. So first we will start with the anode, and this is anode is a negative connected to the negative terminal, and here it is connected to the positive terminal. So here anode is nothing but a negative electrode, where it is oxidizes into by liberating the electron. It oxidizes by liberating electron, The general formation will be like M will convert into Mn plus with the liberation of electron. Here the oxidation process will take place. Whereas in the cathode will be a positive electrode. Where reduction will take place. And reduces ion or atom from anode to cathode. It permits the flow of, it helps in the transportation of ions. So third, fourth, lastly it is a separator. So separator is nothing but a medium which separates the anode and cathode. For the chemical reaction, whenever the chemical reactions will take place, the separator is a very required component which will bifurcate the anode and cathode, so that the reactions can go through very easily without any mixing of the reactant and product. So here the separators are generally used separators are cellulose. So in today's class I am going to explain you some of the modern batteries that includes sodium ion battery, lithium polymer battery and redox flow battery. So these all three batteries we will study in detail in this module. So first we will go with a sodium ion battery. So what is this sodium ion battery? So the name itself suggesting it is a containing of sodium ion. So the battery that stores energy by using the sodium ion. So it is a device, sodium ion battery is a ion battery is nothing but a storage device, that uses a sodium ion, to shuttle a positive charge, between anode and cathode, that thus it converts chemical energy into electrical energy or vice versa. So here it is using a sodium ion to shuttle a positive charge between anode and cathode. So that's why it is known as sodium ion battery. Here it can convert from chemical energy to electrical energy or vice versa. The reverse case is also will be observed. So the basic construction of this sodium ion battery, you can see the diagrammatic representation. Here it consists of 4 components as we discussed in the previous class. It is consisting of, every battery will consist of 4 basic components. One is anode, another one is cathode, electrolyte and fourth one is separator. So here in the sodium ion battery we have the cathodic compartment and anodic compartment, and both are separated by a separator, and there in between we have a electrolyte flow, and here we have a cathode current collector at the end and anode collector at the end, current collector at the end, and the electrons flow can be observed through a external circuit and power supply. So here initially the cathode and anode compartment is very important. So the anode compartment here, the anode electrode is nothing but a hard carbon or a distorted graphite whereas cathode is a sodium metal intercalated with metallic oxide, So the general formula for this cathode is NaMO2. So the metal can be either cobalt or nickel. And third one is electrolyte. So electrolyte is nothing but a medium where it helps for the movement of atoms or ion from one electrode to another electrode. Here the electrode which we are using is NaPF6. So in an organic solvent. And fourth one is separator. So what is the separator that we are using in this sodium ion battery is a cellulose A cellulose is a separator which is used in the sodium ion battery. So as we are seeing the 4 compartment, here we need to observe the materials which is used in the battery. So one is a hard carbon or a distorted graphite, and second one is sodium metal intercalated with metallic oxide. So here the intercalated means the atoms or the ions coming from one electrode to another electrode and start embedding into the surface of the another electrode. So here at a particular position the atom or the ion is going on settling on the electrode. So this settling of ions or atom from one electron to another electron, and this process of embedded or settling is known as intercalation. Here both are porous electrodes, so it have a places or a position so that the atoms can come and positioned on the respective places, and this process is called as intercalation. So that's why it is known as sodium metal intercalated with metallic oxide. So generally it will be a formula, it will be the NaMO2. And third one is electrolyte. Electrolyte is NaPF6. So sodium hexafluorophosphate along with a separator as cellulose. So this is a component and representation of the sodium ion battery. So now we need to go with the working principle of the sodium ion battery, how it's going to work. So in the batteries we have 2 conditions, one is charging, another one is discharging. So in the case of charging and discharging, first we will see with the discharging process. Working principle, under that first we will have the discharging reaction or a discharging condition. Discharging reaction. So in discharging reactions what happens? At anode, generally at anode what happens? At anode oxidations will takes place. At anode oxidations will takes place, and at cathode reduction will takes place. At cathode reduction will takes place. At cathode reduction will takes place. So in this sodium ion battery, during discharge reaction at anode, the sodium atom converts into sodium ion. It's converted into sodium ions. It converts into sodium ion, so that by liberating electron. So this sodium ion start moving from anode to cathode. So at cathode reduction has to take place. At cathode what happens? The metallic oxide starts accepting the electron, and here the sodium metal ion along with the electron, it forms NaMO2, sodium metallic oxide. So the overall reaction is NaC plus MO2 will give you NaMO2 along with C. So now during discharging process what happens is the sodium atom gets converted into sodium ion, and thus the sodium ion start moving from anode to cathode through the electrolytic medium and settles on the sodium metal. And here after discharging condition, if we want to go for recharging condition, so after complete performance of the battery, again we need to charge. For example, like cell phones, once the battery is coming down and it is completely consumed, then we are going to charge this battery, right? In the same way, we have to charge the batteries by applying a external power source. By applying a external power source, that too the voltage should be higher than the voltage produced by the battery. So whatever the external power we are giving, the voltage should be high than that should be produced by the battery. So once the external source is applied, what happens? Here the reaction is reversed. Here the reaction is reversed, and what happens is the sodium ion which is in the cathodic compartment will start moving to the anodic region. So sodium ion starts move from anode to cathode to anode. So the sodium ions during charging condition starts moving from cathode to anode, and thus the reaction is reversed, and the same way the electron flow movement will be takes place from cathode to anode. So during charging reaction, so during recharging reaction, sodium ions moves from cathode to anode, from cathode to anode through the electrolytic solution. So and thus the reaction is reversed. See, for this reaction will be plus NO2, and this is a discharging reaction and charging reactions for the sodium ion battery. So after discussing this, after the recharging reaction, the sodium ion starts move from cathode to anode, where they were embedded in the layer of the electrode. So here the ions moves from one region to another region based on charging and discharging process, and hence it is also coming under the category of secondary batteries, where it is rechargeable, where it is considered as a rechargeable batteries. So then we need to study about the advantages of this batteries. What are the advantages of this battery? What advantages we can observe in these batteries? So here the batteries are low cost, it is consuming of low cost, and it is eco-friendly. We have to discuss the advantages and disadvantages also. Advantages. So they are low cost and environmentally friendly. Environmentally friendly, and it is having a safety characteristics. When compared to other batteries, it is having a safety characteristics. Safety characteristics. Safety characteristics, and apart from that, it is having slightly lower energy density. It is having slightly lower energy density, and high efficiency. So these are the few advantages of sodium ion battery. And if we come for the disadvantages, what is the disadvantages of this sodium ion battery? So sodium ion battery is having a less power production. So it is having a less power production. It is having a less production is having a less power production, and also the major disadvantages observed is here we are using at the anode as a distorted graphite. So, this distorted graphite has a much less absorption of sodium ion. So, the distorted graphite has a distorted graphites absorbs less sodium ion, absorbs the sodium ions, absorbs the less sodium ion. So, these are the advantages, applications and disadvantages of the sodium ion battery. So, after this, so we need to have the applications of the batteries. Where we will use this batteries, sodium ion batteries? Generally in the rechargeable conditions. For example, cellular phones, laptops, yes, right, in the cellular phones, laptops and electronic vehicles. So, where we can use this sodium ion batteries. So, applications of the sodium ion batteries are it is used in cellular phones, laptop and also in electronic or electric vehicles. In electric vehicles where it is a rechargeable components. So, these are the few examples, applications of advantages and disadvantages of the sodium ion battery.